All right, so we've expanded a little bit on physical, conceptual type stuff in the 4 modes as well as numerical. Now, next we're going to do is look a little bit at graphical. Now, you guys have been graphing for a really long time. We're just going to look at a couple things for graphs. Now, we use graphs a lot for lots of different things, and there's lots of really useful things and good information you can extract from graphs. But they have to be done relatively well, and it's really simple, just really basic things about graphs. When you make graphs, in order to make them as useful as possible so you can actually get the best information out of them. Now, of course, graphs are really important in order to see values and see trends and that type of stuff. So let's look a little bit more at graphing or the graphical mode a little bit. And we've talked about this type before. It allows you to see things like values. It allows you to see things like trends as well as connections. It allows you to visualize values a lot better, but you can also extract really important values out of it. For example, you can extract things like intercepts, as well as values like slope, and a whole bunch of other stuff that you can do as well from graphs. And intercepts are really good for trying to get values that you can't actually directly measure, as well as if you want to extrapolate or interpolate, where you go past your values or go in between your values. It allows you to get values that you can't actually measure directly. And there's also slopes, which we calculate to get further values. Of course, you guys, when you grade 10 science, you guys do basic kinematics, and take a distance time graph, and the slope is the speed. I mean, the slopes do kick in and give us really important values. Now, a couple things about when you actually make graphs and that type of stuff. There's a couple of things that kick in. So, for example, I'm just going to just draw a little, little graph, something like this. And when you make graphs, you want to try and keep in mind, you want to try and keep a few things in mind. What you want to try to do is you want to try and maximize your space. You don't want to be crushing things and making them really small. So you want to try and maximize your space as best you can and use as much of the area as you possibly can. So it's not all squished into one tiny little area, because then you can't really see what's going on. You don't want it too small. Now, how far do you go? And you got to watch your numbers and that type of stuff, but you want to try and you also want to try and go up by easy values. And of course, this has a lot to do with the table of values or quantities you're actually using to make your graph. So a lot of times, you go up here. You don't want to go up by weird values and stuff that, you want to go like 2, 4, 6, 8, or 1, 2, 3, 4, 5, or 5, 10. Go up by easy values, and you want to try to maximize your space. So if you are all the way over here, and let's say, we got 1, 2, 3, well, let's just say this is 5, but your highest value in your table is 2, then your graph's going to end over here. Why wouldn't you make it twice as big and try and maximize the space? And just go up by easy values are going to try to help you maximize your space and make it easy for you to find out where values actually exist. And you also got to make sure that, you don't have stuff like this going on. Like that's total garbage. That's not going to work out very well. You want to have things evenly spaced out. So try and go up by nice, easy values when you can. Like 2s and 4s, 5s, 10s, stuff like that. Sometimes people will use things like, like 7, 14, 21. I think that's way too complicated. But you want to try and maximize space, go up by easy values. You'll often see things like, like 1, 2, 3, 4, 5. Like 5, 10, 15, 20, 25. And it doesn't really matter if your values are actually these values. It's all about having a nice space to work with, easy to find in between values and stuff like that. Okay, so try and maximize your space, go up by easy values, that type of thing, but also leave some room. Leave a little bit of room in order to actually, for lack of a better word, get a little room to grow. So if your top value was actually 5, I might actually go to 6 in case I want to extrapolate or I want to predict a little bit further. It's nice to have a little bit of room to actually make the graph a little bit bigger if you want to. So Go up by easy values, but give yourself a little space. Not too much space where it's going to squish your graph being really, really small. You want to maximize that space as best you can, but also leave a little bit of room to make it work well. Okay. Now, when you're plotting your points and you're making your dots, make your dots or your points, whatever in your graph. This, like, the word I like to think about is make them nice and healthy. Okay. Now, what I mean by that is you don't really want something that looks like little tiny little nub things like this. Try to make them healthy. Make them good sized dots. Don't go crazy. Don't make them huge. But make them actual healthy dots. So first of all, so you can actually see them. Okay, especially if you're going to draw a line or a curve or something like that, you want to be able to see them. If your dot's too small and you draw a line or curve through it, well, you could just go right over it. You won't even see the point anymore. You might want that coordinate for something. So make them healthy so you can actually see them. But the other thing it allows to do is it actually allows for a little bit of error, a little bit of give. So you don't necessarily know that point is exactly on the graph, the exact right measurement, exactly everything's correct. So by making it a little bigger, you sort of give it a little cushion around it that the measurement's around this location. Okay, so try and make them healthy. All right. Now, after you're done that, you often want to be able to draw a line or a curve. Now, you're going to have a line of best fit. You've probably heard of that term before, but it could also be a curve of best fit. Now, the key right there is best fit. It's not about hitting all the dots. It's about a best fit. Now, when you do this, it should, especially if it's a curve, it should be nice and smooth. It shouldn't be changing direction. It's not about hitting dots. It's about being nice and smooth. It shouldn't curve up, then curve down. It should just curve up or down. It shouldn't wiggle back and forth. If it's a straight line, it's a straight line. Use a ruler and make a straight line. It's not about actually hitting the dots. You do want them to be, try and make them symmetrical and stuff like that. But it's more important to have a smooth line and especially a smooth curve. And we'll get to a little bit more of that a little bit later on. Also, when you do that line of best fit or a curve of best fit or whatever you want, it's a really good idea to try and predict critical points like the origin. Like, does it go through the origin? Does not go through, because you can use that origin as a good anchor point. And sometimes it helps to make your curves and lines a little bit better. So if I was going to draw a curve for something like this, it's not this, that's terrible. Okay, I hit every dot, but that is absolutely terrible. We wouldn't be able to use that for anything. So what I'd want is something more, that's not too bad. That's smoother. Okay, it's not too bad actually, and I'm only hitting a couple of the dots, but that's not the point. The point is to have a smooth general trend so I can actually apply it and use it for stuff, and we'll get to that in a little while. So these are some of the keys for making graphs. Make them a good size so you can see the values better. Go up by easy values. Don't make it hard on yourself, but give yourself a little bit of room to grow on either axis in case you want to extrapolate. Okay, make your points healthy so you can actually see them, give yourself a little bit of error, and then when you draw your line, if it's a line, make it a line, make it straight. If it's a curve, make it a curve, and make it nice and smooth. No wiggling around. You want nice and smooth. Okay, and I'll show you why that's really, really important in just a second, because we're going to focus a little bit on that whole slope idea. Okay, so let me clean this up a little bit, and then we'll look at why that whole smoothness is really important. So I cleaned some stuff up here and I got rid of a bunch of the junk that was around there, and I took this exact same graph that we had and I just sort of magnified it. Now, this sort of will show why that whole smoothness thing is really important. First of all, the whole smoothness thing is that the line or curve sort of averages out the points, and you want a general smooth average. But there's something else that kicks in, and it sort of kicks in with slope. Slope is one of the most important quantities out there for graphs, no question. It is used so much for there's a reason why it's for grade 9, grade 10. You guys use so much slope calculations because now it starts kicking in and applying it to stuff. Now, if it's a straight line, that's really simple. You got your basic line, you've got your delta y, or your delta x, or your rise over run, however you want to remember it, whatever. You've got all that kind of stuff. But what if it's a curve? If you have a curve, you have to do something else. Now, of course, if it's a curve, it doesn't have a slope. It actually has multiple slopes. And when you have a curve, what you can do is you can find the slope at a point. Now, let's sort of go back to grade 10 a little bit. If this was a distance time graph, you guys remember that slope on a distance time graph is speed. And of course, in a distance time graph like this, a straight line, that just means constant speed. But in a distance time graph that's curved like this, you guys remember that means it's going faster and faster and faster. But there's still speed, but the speed is always changing because the slope is always changing. So instead of finding the slope for the entire thing, you can find the slope at a point, and this is what's called finding the tangent, or slope at a tangent. Now, what you do is you sort of pick a point. Maybe I want this point right there, okay? And I want to know the speed at that time. Maybe it's 4 seconds or something like that, according to my graph here. So what I want to do is I want the slope at that point. Well, I don't have a straight line, it's a curve. So since I don't have a straight line, I am going to make a straight line. And the idea, I can use my fancy computer stuff here, is to do something like this, where you draw a line that skims the curve, and it's called a tangent. And I can find the slope of that tangent line in order to get the slope at that location. Now, obviously, if I did it right over here somewhere, it'd be a lot flatter because, again, if this is a DT graph, the speed is really slow at the very beginning. It goes faster and faster and faster. So the whole thing is you want to draw a tangent to the curve. Now, when you draw the tangent, there's a couple things you're looking at. First of all, it should be really symmetrical, just on either side. The gaps on either side should be about the same. You don't want to curve too much this way or slant it too much this way or this way. And there's different strategies people use to actually try and get good tangents. But one thing is I typically do is I look a little bit to the right, I look a little bit to the left, and see if I've got the same amount of curvature or space on either side. And if it's about the same, then it's probably a good tangent. And then I just have to find the slope of that tangent. And I would typically use that point right there, as well as the intercept, because it's really easy. Find the slope of that tangent, and then I can calculate whatever value. In this case, it would be speed. Okay, now this is one of the critical things of why when you make a curve, it's got to be smooth. You can't do this properly. If I sort of redrew this here, if I did the same thing before where I'm sort of like connecting the dots, something like this, like this, that's terrible. Like, how are you supposed to draw a tangent on that, on this wiggling thing? It's not smooth. I mean, you got a tangent here, you got a tangent this way, you got a tangent, like, this is ridiculous. Like, you can't, it should be smoothly changing, not going all over the place. So if you don't draw smooth curves, it makes doing things like tangents and other types of graphical analysis very, 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 very difficult. But also it shows that, if it's nice and smooth, that you're sort of averaging things out. So again, if it's a straight line, make it a straight line. If it's a curve, make it a curve, but make it nice and smooth. This one curves up. Well, then it shouldn't be curving down later on, okay? Don't wiggle it around. Don't try and make it get points. Try and make it smooth. Try and make it symmetrical with the points and stuff that, not have all the points above it or all the points below it. Try and make it symmetrical, but try and make sure that it is smooth. So when you actually want to use graphical type analysis like tangents, it is actually possible and can work really well. Okay, so we're talking about making a tangent. It's a slope at a point. And then what you do, all you have to do then is find the slope of that actual tangent, and that will give you the slope at that location. Okay, so again, this is why when you're making graphs, it's all about them being nice and smooth. Okay, now of course, a lot of this is done by drawing by hand, which means when people do it, it's not uncommon for people to have slightly different values and that type of stuff. There's nothing wrong with that. That's just the way it is. Okay, but it's a really important thing for it to be smooth, good spacing in your points. I'm sure you can see if your values aren't spaced out nicely, your graph is going to get distorted, which means your slopes are going to get distorted. Your tangents will be distorted, and everything can be skewed and everything can be off. So you want to go up easy values. You want to go with nice even spacing. Make it a good size. Again, if this graph was too small, it'd be really hard to make a good tangent and read the points. and make things nice and smooth, and your results will end up working an awful lot better.